For today's lesson, we will be working with equivalent ratios. And equivalent ratios are very similar to work with equivalent fractions. And our standard that we will be focusing on today is 6 RP3A. So Emma has some marbles. So one way that Emma could write the ratio for the marbles is she could count how many red marbles she has and how many blue marbles she has, and she could write the ratio of 8 to 12. But maybe Emma decides to look at them in pairs instead of as individuals. So if she looks at the number of pairs she has 4 pairs of red marbles, and she has 6 pairs of blue marbles, so she could also have a ratio of 4 to 6 because she's looking at pairs instead of individuals. Now, one thing to notice is that the actual number of marbles didn't change, but our ratio changed based on how we were grouping them. Or Emma could have decided to put her marbles into groups of 4, which in this case would turn her ratio into 2 to 3 because she has 2 pairs, or she has 2 groups of 4 marbles, and she has 3 groups of 4 blue marbles. And again, the actual number of marbles didn't change. It was just how Emma was grouping them. So the ratios 8 to 12, 4 to 6, and 2 to 3 are what we call equivalent ratios because they all stand for the same thing. So here we have some pencils and some erasers. So we could write different ratios based on how we look at this picture. So one ratio to describe the number of pencils to the number of erasers would be 10 to 20. Because if we count all of our pencils, we would have 10 pencils. And if we count all of our erasers, we have 20 erasers. If we looked at pairs of pencils to pairs of erasers, our ratio would be 5 to 10 because we have 5 pairs of pencils and 10 pairs of erasers. We could also have a ratio of 2 to 4. We have 2 sets of 5 pencils and we have 4 sets of 5 erasers. And our final ratio we could write is 1 to 2. We have 1 set of 10 pencils and we have 2 sets of 10 erasers. Excuse me. So when putting ratios in simplest form is very similar to putting a fraction in simplest form. We want to try to divide both terms of our ratio by the same number. So if we're going to express the ratio 50 to 20 in simplest form, since both 50 and 20 end in a 0, that tells us that we can divide both of those by 10. So we would get the ratio of 5 to 2. For number 2, if we want to express the ratio of 8 centimeters to 3 meters in simplest form, we have to go back to what we did in the previous lesson and we have to do that conversion. So in the previous lesson, we found out that 1 meter is equivalent to 100 centimeters. So 3 meters would be equal to 300 centimeters. Scroll down a little bit. So that would give me a ratio of 8 to 300. Now you should be able to recognize that both 8 and 300 are even numbers, which means at a minimum, you can divide both of those terms by 2. So if we divide both of those by 2, 8 divided by 2 is 4, 300 divided by 2 is 150. Again, you look at the two terms, you notice that they're both even numbers. Remember, even numbers end in 0, 2, 4, 6, or 8. And we can divide those by 2 again. And we would get the ratio of 2 to 75. If you recognize from the beginning that you can divide both 8 and 300 by 4, then absolutely divide both of them by 4 and get it done in one step as opposed to taking 2 steps. But as long as you get that ratio down to 2 to 75, I'll be okay with that. So we have our ratio of 12 to 64. Well, you can divide both of those by 4, and you'd get an answer of 3 to 16. And again, if you started by dividing those by 2, which would give you 6 to 32, and then divide those by 2 again, you would get that answer of 3 to 16. Okay. Now for number 2, we have another one where we're going to have to do some converting. But we can actually do this in a slightly different way than we did the previous one. And the reason for that is we can divide both 7 and 21 by the same thing. So we can divide both of these by 7. And 7 divided by 7 is 1, so we'd have 1 kilogram. And 21 divided by 7 is 3, but it's written as 3 grams. Okay, now we still have 2 different units of measurement here, and we need to make sure that we convert them into 1. Well, in our previous lesson, we learned that 1 kilogram is equal to 1,000 grams. So our ratio here is 1,000 to 3. So in these situations, you have to remember to do both things. You have to remember to simplify, and you have to remember to convert. And you can actually do them in either order. In the previous example where we had 8 centimeters to 3 meters, we had to convert first because we couldn't divide 8 and 3 by the same thing. But here, we were able to divide 7 and 21 by the same, so we divided first and then did our conversion second. Sorry, I lost the word there for a second. Excuse me. All right, so we have pairs of ratios, and in one ratio, we're missing one of the terms. So just like in a fraction, when you're writing equivalent fractions, numerators go with numerators, denominators go with denominators. In ratios, the first terms go together and the second terms go together. So in the ratio 4 to 5 equals 12 to something, the 4 and the 12 go together. They work in a pair. So you just have to ask yourself, well, how do you get from 4 to 12? You get from 4 to 12 by multiplying by 3, which means you have to multiply 5 by 3 to get 15. And the ratio 42 to 54 equals something to 9. 9 is the second term, as is 54. So to get from 54 to 9, you have to divide by 6, which means you have to divide 42 by 6 to get 7. Now there will be some situations, as described in this example, where we know that 36 goes to 15. However, there's nothing that we can multiply or divide by easily to get from 36 to 15. So in these situations, we have to look at that first ratio. And that first ratio that we have is 36 to 12. Well, 36 to 12 is not in simplest form. So our solution here would be to simplify 36 to 12, and we can divide both of those by 12, and we get the ratio of 3 to 1. Well, we can take 3 times 5 to get 15, so we would take 1 times 5 to get 5. So look for that in some of the problems that you have to do that you might have to simplify before being able to convert. To get from 64 to 8, we have to divide by 8. So 48 divided by 8 is 6. To get from 4 to 36, we have to multiply by 9. So we take 9 times 9 to get 81. 5 goes with 35, and we have to take 5 times 7 to get 35. So we take 7 times 7 to get 49. And then to get from 42 to 7, we have to divide by 6. So we divide 54 by 6 to get 9. So we have a table here showing the different amounts of tea and milk used to make cups of milk tea of different cup sizes. So if we're looking at amount of tea to amount of milk, and we look at that as a ratio, well, since they both end in 0, we can get rid of the zeros. We can divide both 18 and 6 by 6, which gives us a ratio of 3 to 1. 27 and 90, those both end in 0, so we can get rid of those by dividing by 10. And we can divide both 27 and 9 by 9, and we get, once again, the ratio of 3 to 1. 360 to 120, again, we can take those zeros off, and this one we already simplified a little bit ago, and we also know that ratio is 3 to 1. 450 to 150, we take off the zeros, divide them both by 15, and look at that, we get the ratio of 3 to 1. And finally, column E, divide both of those by 18, and we get the ratio of 3 to 1. And that's usually how ratios work, is you have that initial ratio, you need 3 parts of tea to 1 part of milk, and then depending on how much you use of one, that'll determine how much you use of the other. And you want to keep those ratios consistent as you go through. So here, if we fill out this table, so if Mrs. Smith has in column B a cement to sand ratio of 8 to 6, well, if you simplify that, you get 4 to 3. And if you write it in the form of a fraction, you get 4 to 3. For column C, the cement to sand ratio is 12 to 9. You simplify that, you get 4 to 3. You write that as a fraction, you get 4 to 3. And for column D, cement to sand ratio is 16 to 12, which simplifies down to 4 to 3, which is in the form of a fraction, is 4 to 3. So for every parts of cement you use, you want to use 3 parts of sand to keep that ratio and that mixture consistent. So to make 1 portion of dough, Sophia mixes 5 cups of flour with every 3 cups of water. So to find the ratio, or find the ratio of the amount of flour used to the amount of water used to make 1 portion. Well, the amount of flour she uses is 5. The amount of water is 3. So our ratio is 5 to 3. Excuse me. So for part B, Sophia wants to make 5 portions of dough. How many cups of flour and how many cups of water does she need? Well, if the ratio of 5 to 3 makes 1 portion, to do 5 portions, she would need 25 cups of flour. And she makes 5 portions, she would need 15 cups of water, because you'd have to do each of those 5 times. Okay, so that's one way to do your answer. Or if you wrote your answer as the ratio 25 to 15, I would take that answer as well, because it does answer the question that we're looking for. And then part C, Sophia uses 21 cups of water to make the same type of dough. How many cups of flour does she need? Well, she needs 35 cups of flour, because 3 times 7 gives you 21, so you have to take 5 times 7 to get 35. A recipe for each bowl of yogurt of a yogurt and cereal mix uses 3 tablespoons of cereal for every 2 tablespoons of yogurt. So the ratio of the amount of cereal to the amount of yogurt is 3 to 2. Mrs. Brown wants to make 4 bowls of the yogurt and cereal mix. How many tablespoons of cereal and how many tablespoons of yogurt does she need? Well, she's doing that 4 times. She needs 12 tablespoons of cereal, and she would need 8 tablespoons of yogurt. Or, just a reminder, you could write it as a ratio of 12 to 8. Mr. Gray uses 24 tablespoons of cereal. How many tablespoons of yogurt does he need? Well, he would need 16 tablespoons. Okay, a couple ways. The original ratio was 3 to 2, so 3 times 8 is 24, so 2 times 8 is 16. Or if you look at our previous answer, there's 12 tablespoons of cereal. 12 times 2 is 24, so 8 times 2 would give you 16. Recipe uses 200 milliliters of apple juice concentrate for every 500 milliliters of water to make a drink. So we want to find the ratio of the amount of apple juice concentrate used to the amount of water used. Well, apple juice was 200, water was 500. So in this one, you could have 200 to 500, or if you did want to simplify that down to 2 to 5, that works as well. So we want to find the missing numbers in the table. So we're basing everything off of that ratio of 200 to 500. On that first missing box, to get from 500 to 250, we have to divide by 2. So we divide 200 by 2 to get 100. To get from 200 to 600, we have to multiply by 3. So we're going to take 500 times 3 to get 1,500. To get from 500 to 2,500, we have to multiply by 5. So we take 200 times 5 to get 1,000. And to get from 200 to 1,400, we have to multiply by 7. So we take 500 times 7 to get 3,500. And finally, if Valeria uses 800 milliliters of apple juice concentrate to make the same drink, how much water does she need? Well, to get from 200 to 800, we have to multiply by 4. So we take 500 times 4 to get 2,000 milliliters. All right, I'm going to switch presentations here quickly. Erase this information. I'll explain it here in a second. But instead of making two separate ones for where we just kind of go quickly through the second part, we just didn't have enough time in class to do both parts. I'm just going to go ahead and do that video now. Okay. So, here we go. Excuse me. The ratio of the number of students from Class A to the number of students from Class B at a concert is 4 to 5. The ratio of the number of students from Class B to the number of students from Class C is 10 to 9. We want to find the ratio of the number of students from Class A to the number of students from Class B to the number of students from Class C at the concert. So we want to take our two ratios and combine it into one. Well, the first ratio we're given compares Class A to Class B, and that ratio is 4 to 5. Our second ratio compares Class B to Class C, and that ratio is 10 to 9. So if we look at our two ratios, we notice that Class B is in both ratios. And if we look at the terms, we have a 5 and a 10. Well, there's a connection between 5 and 10. 10 is a multiple of 5. So what we can do in this situation is we can write an equivalent ratio for our first one. And we know that 5 times 2 is 10. So if we take 4 times 2, we get 8. So if we write our ratio of A to B to C, we get a ratio of 8 to 10 to 9. The ratio of the area of rectangle A to the area of rectangle B is 7 to 11. So A to B is 7 to 11. The ratio of the area of rectangle A to the area of rectangle C is 21 to 40. and we want a ratio for A to B to C. Well, in both ratios, rectangle A, the connection is that 21 is a multiple of 7. So we would take 7 times 3 to get 21, which means we take 11 times 3 to get 33. So our ratio of A to B to C is 21 to 33 to 40. And that's all for lesson 4.2. As always, I hope this helps.